One way that we can calculate the greatest common divisor between two integers is to calculate the product of primes and then take the smallest exponent of the common bases. Another method is the Euclidean algorithm using the mod operator. So let's use the Euclidean algorithm to find the greatest common divisor between 189 and 24. The first step in the process is to take the larger of the two numbers and mod it by the smaller of the two numbers. This is going to give us 21. The second step in the process is to take the 24 and we're going to mod it by the 21, which was our remainder, and this is going to give us 3. We're going to continue this process until my remainder is 0. So the next step will be to take the 21, I'm going to mod it by my remainder of 3, and this is going to give me a 0. That's what I was waiting for. As soon as I get a remainder of 0, the number that I modded it by, or the remainder, is going to be my greatest common divisor. So the answer to this is 3. So if 3 is my greatest common divisor between 189 and 24, the extended Euclidean algorithm would state that that greatest common divisor can be expressed in terms of multiples of 189 and 24. So the greatest common divisor of x and y is s times x plus t times y for some value s and t. So let's see if we can find the greatest, or this expression, for 189 and 24. We know that the greatest common divisor for 189 and 24 is 3, so we say that 3 can be represented by s times 189 plus t times 24 for some value s and t. So I'm going to write down the original 3 steps that we used to generate this 3. We can find the values of s and t by substituting the mod operator with the equation minus y divided by x. So let's start with step 2, and we're going to replace the mod operator in step 2 with minus y divided by x, and we're going to work our way backwards using substitution into step 1 until we can finally find the values of s and t. Step 2 says that 3 is equal to 24 mod 21. If you don't mind, I just rearranged the equation so that 3 is on the other side. What I'm going to do is I'm going to substitute the mod operator with a minus y divided by x. This is going to be a minus 24 divided by 21. So this will give us 3 equals 24. That mod operator is going to be substituted with a minus 24 divided by 21 times 21 on the end. Now the division, or this 24 divided by 21 is going to be integer division. This is going to give me a 24 minus 24 divided by 21. Integer division is 1. I'm going to multiply that by 21. I want to keep this equation in terms of 24 and 21, so when I simplify it, we're going to have 24 minus 1, 21. But step 1 tells me that 21 is actually 189 mod 24, so I'm going to write that down. Once I have it written down, I'm going to replace the mod operator again with a minus x divided by y, a minus y divided by x. That's going to be a minus 189 divided by 24. So the equation that I'm going to have now is 21 is equal to 189. I'm replacing that mod operator with a minus 189 divided by 24, and then I have that multiplied by 24 on the end. Once again, I'm going to simplify this, keeping it in the terms of 189 and 24. This will give me 21 is equal to 189. This is going to be a minus 189 divided by 24. Once again, this is integer division, and that is going to give me a 7 multiplied by 24. I want to keep it in terms of 189 and 24 because those were my 2 original values. I am at step 1, and we were trying to find the greatest common divisor between 189 and 24. So when I simplify this, I'm going to keep those terms. So I have 21 is equal to 189 minus 7 24s. So let me come back to step 2 for just a minute. Oh no, I just noticed that this is actually supposed to be a 4 and not a 1. My apologies. So I'm going to write this down here. We said from step 2 that 3 is equal to 24 minus 121. We have also just determined that 21 is equal to 189 minus 7 24s. So if 3 is equal to 24 minus 121s and 21 is equal to 189 minus 7 24s, what I'm going to do is I'm going to replace this 21 right here with the value that it is equal to. I'm going to push this down just a little bit to give myself some room, and I'm going to replace the 21 with the equation that it's equal to. So if I replace the 21 with the value that it's equal to, what I'm going to get is 3 is equal to 24 minus 1. Well, the 21 is actually equal to the equation 189 minus 7 of the 24s. And I am going to simplify this equation. I do want to keep it in terms of 189 and 24. So when I simplify it, we're going to get 3 is equal to 24 minus, I'm going to distribute the 1, so I'm going to get a minus 1, 189. And then I am going to distribute the minus 1 times a minus 7 24s. So I distributed the 1 through the parentheses. I'm going to simplify it even farther, keeping it in terms of 189 and 24. This is 24 minus 1, 189. This is actually going to be plus 7 24s. So as I look at this equation, I can see that I have 7 24s over here, and I have 1 24 over here. So I'm going to simplify it even further in terms of my original values of 189 and 24. This is going to give me 7 24s, and 1 24s are ultimately going to give me 8 of them, 8 24s. And then I see that I have minus 1, 189. So 3 is equal to 8 24s minus 1, 189. This is giving me the value of 3 in terms of S, 189. I think I just wrote it backwards, plus T, 24s. I can see that in the equation that the value S is the number that is multiplied by my 189. So S is equal to a minus 1, and I can see that my value of T is equal to 8. So let me push this down a little bit and prove it. Let's see if 3 actually is equal to 8 24s minus 1 89s. Well, if I do the math, I can see that 8 times 24 is 192. And then we're going to subtract off 1 times 189, which is going to give me 189. And this number is indeed equal to 3. So this gives me my values of S and T using substitution, where I substitute the mod operator with a minus y divided by x. And that division is integer division, not floating point division. So the couple of things that I would like to mention before we're done. When we started the process, and I said that I wanted you to keep step 2 in terms of 24 and 21, the reason why I wanted you to keep them in terms of 24 and 21 is step 2 is actually made up of the values of 24 and 21. And this became very, very important because when we moved upwards to the next step, we had our equation in terms of 21. And then when we moved to step 1, I said to keep this value in terms of 189 and 24. That's because those are the original values of the two integers that I was finding the greatest common divisor of. And ultimately, I needed to be able to replace this 21 with some value of 189 and 24 because I needed to know how many 189s and how many 24s would make up my 3. So this can be a little bit complicated. The best way to do this is to work out each step of the greatest common divisor, and then start at the bottom with the step immediately before you reach to 0 and the remainder, and work your way back up each step, replacing the mod operator with the values of x and y.